Hello everyone. Welcome to the Reaction Chemistry. So my name is Ankit Dhiman and I am pursuing my master degree in IIT Jammu. So today we are discussing some name reaction involving in carbonyl group. It is very important in perspective with the IIT JEE in your competitive exam, IIT JEE like IIT JAM and CSIR NET. So let's see what is the name reaction we have. First, we have the Stephen reduction, which is also known as a Stephen reaction, in which we have acetonitrile group in presence of SnCl2 and HCl. It reduces into aldehyde. So let's see what is the mechanism behind its reaction. So in first step, we have nitrile group. In presence of acidic condition, the lone pair of nitrogen abstract the proton from HCl and making a intermediate. Then further we have SnCl2 in reaction. Basically SnCl2 is a reducing agent. It's reduce the molecule and give the 2 electron in reaction. So Sn plus 2 convert into Sn plus 4 and it's give 2 electron. The 2 electron basically transfer into carbocation and we have carbon anion in this reaction. Further, we have H positive in this reaction, abstract by the carbon ion. Further, if we hydrolyze this reaction, the lone pair of oxygen attack to the carbon group, and the pi bond of carbon and nitrogen transfer into nitrogen group. So let's see what is going on here. Oxygen, OH, nitrogen, and negative charge. H2 positive. The negative charge of nitrogen abstract the proton from the H2O molecule, and like this, OH and H2. Further, in acidic condition, the lone pair of nitrogen abstract the proton from the H2O molecule, or you can say HCl, and convert into ammonia. And lone pair of oxygen introduced in the molecule, and NH3 molecule will come out from the reaction. So we have aldehyde group as a product form, and the side product we have ammonia gas. So this is the reaction behind the Stephen reduction. It is a simple reaction and important for your JEE exam. So let's move further. We have another reaction. Another reaction we have a Razan-Amont reduction. This is a reaction in use formation of aldehyde from the acid chloride. Acid chloride. So let's see what is the mechanism behind this reaction. In substrate form, we have acid chloride, and we have a catalyst as a palladium L4. So palladium L4 react with acid chloride. Basically, it's insert in between carbon and chloride bond like this. Oxygen, palladium, and Cl, and 2 ligand will come out. So here we have 2 ligand. Further, we have H2 in reaction, replace the 2 ligand of the palladium complex, and this is intermediate we have Cl, hydrogen. Further, the reductive elimination will take place and come out HCl plus aldehyde group and the palladium. So this is a catalytic reaction. in which the palladium catalyzed will be used. So let's move further, and we have another reaction. Another reaction, we have a Clemenson reduction. So this is reduction of the aldehyde into alkane group. So let's see what is the mechanism. So every reaction, the mechanism is very important. We have aldehyde and 4 hydrogen group. It is a proton. So if we protonate this molecule, like reduce this molecule, the addition of the hydrogen is known as a reduction. So we have a zinc Cl and we have HCl. The lone pair of oxygen extract the proton from the HCl, like acidic condition. In acidic condition, OH and positive charge will create on the carbon atom, and we have a zinc chloride attack on the positive charge and making a intermediate like this. Further, zinc metal or zinc amalgam attack on the chloride group, or the negative charge will produce on the zinc, carbon OH, hydrogen and zinc negative. The OH molecule will convert into H2 molecule in a as a leaving group and come out from the reaction. So we have another carbocation, zinc, negative charge and lone pair of zinc. The negative charge, or you can say the lone pair of the zinc, will introduce or delocalization in the molecule, and carbocation will convert into carbon ion like this, and zinc positive. So we have H positive in this reaction abstract by the carbon ion, and it's converted into methylene group and zinc positive. Further, one H positive abstract by the, or you can say replaced by the zinc positive, and we have alkane in the reaction, or you can say as a product. So you, if you can see, we if you can see in this reaction, the 4 proton will be used for the reduction of the aldehyde into alkane. So this is the simple mechanism. Let's move further. We have another reaction, Wolff-Kishner reduction. It's important reaction, and the wide use with industrial application, or you can say of complex molecule synthesis, and for the competitive examination it is also important. So let's see what is the mechanism behind this. So in Wolff-Kishner reaction, we have NH2NH2. It is a reducing agent. It reduces aldehyde group to alkane. So in first step, we have aldehyde, NH2, NH2. The lone pair of nitrogen attack on the carbonyl group, OH, hydrogen, NH, NH2, like this. Then further, in acidic condition, or you can say nitrogen, a lone pair of oxygen abstract the proton from the nitrogen and convert into in leaving group like this, OH2 positive, and or the lone pair of the nitrogen introduced in the molecule like this, the double bond will form, and we have a hydrogen, H2 will remove out from the reaction, and H2. So this is the reaction intermediate, CH, double bond nitrogen, and NH2. In presence of base KOH, it is a strong base. So the work of the base is abstract the proton from the most acidic side. So the OH negative abstract the proton from the most acidic side, and the negative charge will produce on the nitrogen. Then further, nitrogen NH negative. The negative charge will delocalize in the molecule and the carbon ion will form. CH negative nitrogen double bond NH2. Sorry, NH. Then from the H2 molecule, let's say we have a H2 molecule in this reaction, come out from that molecule. The proton abstract from the H2 molecule by the carbon ion. CH nitrogen double bond NH. Further, in presence of basic condition KOH, so OH negative abstract the proton from the nitrogen and negative charge will produce, and the negative charge will delocalize and the carbon and nitrogen bond pair will come on the carbon atom and carbon ion will form. Carbon ion CH negative charge and N2 nitrogen gas. Nitrogen gas will remove what from the reaction, and further from the H2 molecule carbon ion abstract the proton and convert into alkane. So alkane we have as a product and N2 as a side product. So this is the simple mechanism behind the Wolff-Fresnel reduction. And let's move further reaction. Let's move another reaction. So we have another reaction, aldol condensation. It is a most fundamental reaction used in organic synthesis. So let's see what is the mechanism, or you can say in aldol condensation we have a 2 aldehyde molecule reduced into alpha, beta and saturated aldehyde. So it is a self-condensation reaction type. So let's see in presence of base what's going on in this reaction. So we have aldehyde group, NaOH. So OH is a act as a base here. Or if OH negative act as a nucleophile, then its attack on the carbonyl group, and reaction will not further take place. So OH negative should have to act as a base, and enolate will form in the reaction. So this is the enolate. Enolate will attack on the another molecule of aldehyde. So enolate act as a nucleophile or attack on the carbonyl group. So CH2 oxygen and OH and CH3. So this is the molecule. In presence of acidic condition H positive, or you can say we have a H2 molecule in this reaction, or you can say this is the most acidic site here. From this the proton will abstract by the base here OH negative, abstract proton from the this side, and the negative charge will remove to the oxygen H2 molecule from the reaction. Or you can say first we have convert the OH molecule into H2 as a leaving group. So CH and aldehyde. This is the product we have. So this is alpha and this is beta. So this is alpha, beta and saturated aldehyde as a product we have in aldol condensation. So this is the here the substrate molecule will same like 2 aldehyde molecule will be same. In cross aldol condensation we have a 2 different type of aldehyde. So let's see. So this is a cross aldol condensation in which we have a 2 different type of aldehyde convert into alpha beta unsaturated aldehyde in presence of base and H2O. The H2O will work as a we will use as a workup in the reaction. So let's see what is the mechanism behind this. We have aldehyde. We have aldehyde. CH3. We have aldehyde in presence of base OH negative. It's convert into enolate CH2 double bond O negative hydrogen. The enolate will further attack on the formaldehyde. We have formaldehyde in this reaction. The enolate will attack on the formaldehyde, and we have CH2 hydrogen OH and hydrogen. Or another reaction, or you can say another step, in presence of base, the most acidic proton will be extracted by the base, and negative charge will force to the H2 molecule come out from the reaction. So the H2 molecule converts into leaving group. So let's see, CH2 CH double bond oxygen hydrogen, or you can write this molecule as this type, CHO CH2 CH2. So this is alpha, this is beta. This is alpha beta unsaturated aldehyde. This is a product. So this is a cross aldol condensation in which we have two different type of aldehyde convert into alpha beta unsaturated aldehyde in presence of base and as a workup. So let's move further another reaction. We have a most important reaction. This is a Claisen-Schmidt condensation reaction in which we have a benzaldehyde and acetaldehyde. In presence of base, we have alpha beta unsaturated aldehyde. So let's see what is the mechanism behind this reaction. We have CH3 hydrogen in presence of base NaOH. It convert into enolate, and further enolate will attack on the benzaldehyde. So in benzaldehyde we don't have alpha hydrogen, so making for the enolate. So if base attack on the benzaldehyde first, then will act as a nucleophile. The OH negative have to attack on the carbonyl group, because in benzaldehyde there is no alpha hydrogen to extract as a from the OH negative and to making the enolate. So we have to make enolate from the acetaldehyde, not the benzaldehyde. Then the enolate of the acetaldehyde attack on the benzaldehyde carbonyl group and making alpha beta, and making this type intermediate OH negative OH. Then further in presence of base, OH negative extract the proton and it's remove the H2O from the molecule as a leaving group, and we have alpha beta unsaturated aldehyde in this reaction. So this is a Claisen-Schmidt condensation reaction. So the condensation reaction means the small molecule like H2O, like HCl will come out from the reaction. That reaction will call as a condensation reaction. So let's move further another reaction. We have a Cannizzaro reaction. This is a Cannizzaro reaction. In Cannizzaro reaction, we have a two formaldehyde group in presence of base. It's convert into alcohol or acetic acid salt. So let's see what is the mechanism behind this reaction. So we have a formaldehyde and in presence of base. So let's see here in formaldehyde there is no alpha hydrogen to extract by the OH negative. So OH negative should have to here act as a nucleophile. OH hydrogen hydrogen. Further, in presence of base, the most acidic proton will be extracted by the base, and there is a dianion type type intermediate will form. Then further we have another aldehyde, you can say formaldehyde group in this reaction. The negative charge will resonance, or you can say delocalize in the molecule and force to the hydride group to attack on the carbonyl group of the formaldehyde. So from here we have O double bond oxygen, O negative hydrogen. The sodium metal from the base will going to the oxygen negative and making a acetic acid salt, or you can say, or carboxylic acid salt. So from this we have OH negative hydrogen and this is a hydrogen atom. This is a hydrogen atom come from the as a hydride group. Okay, then in presence of acidic condition, or you can say as a workup, it's convert into alcohol group. Hydrogen this is CH3OH. This is a as a alcohol group. So this is the mechanism behind this Cannizzaro reaction. So let's move further. Let's move to the another reaction. This is Perkin condensation reaction, in which we have a benzaldehyde and acidic anhydride. In presence of acidic salt, it's convert into cinnamic acid or acetic acid. This is alpha beta unsaturated acetic acid, and this is a acetic acid. So let's see what is the mechanism behind this reaction. So let's see. This is acetic and anhydride group. This is CH3 in presence of its derivative salt. So here is we have a negative charge species which is can act as a like a nucleophile, or you can say act as a base. So if it act as a base, it is extract the proton from the molecule and will convert into acetic acid. And if they act as a nucleophile, then will it attack on the electrophile on the in the reaction. So let's see what is the reaction of this you can say reagent in this reaction. So let's see. CH3 double bond oxygen, O negative. If we attack on the electrophile of the acidic anhydride, then let's see what is the product of this reaction. So the delocalization of the pi bond here, and further will come out here, and this group will come out from the reaction, and we have CH3 oxygen double bond oxygen. The product we have the same acetic anhydride, so there is no reaction take place. So this reagent should act as a, or you can say have act as a base here. So there is no you can say there is no benefit if we if we act as a, or you can say if reagent act as a nucleophile. So let's see if reagent act as a base. So this negative charge abstract from the proton most acidic side, or you can say like I'm going to drawing like this. This is 2 and this is hydrogen. So abstract from the proton here, and the bonding of the hydrogen or you can say carbon hydrogen bond introduced in this bond, and this is going to like this and this is going to like this. So this is another type of enolate, oxygen or negative or negative. Okay, so further we have benzaldehyde. We have benzaldehyde in this reaction, CH oxygen. The negative charge will attack on the carbonyl group of the reaction of the benzaldehyde. So OH negative, CH2, double bond oxygen, oxygen, double bond oxygen, and CH3 group. In presence of base, the most acidic proton will be come out, or you can say abstract by the base, and the OH molecule will convert into H2 molecule and come out as a leaving group from the reaction. So we have double bond in this reaction, OH, oxygen, OH, and CH3. So this is the reaction. So this is alpha beta unsaturated acetic anhydride reaction, or so you can say product. But we have H2 in this molecule, or you can say OH negative in this molecule. The OH negative will act as a nucleophile and attack on the carbonyl group. So let's see what is the going on, or you can say what is the product will be form O negative, oxygen, carbonyl group, and OH. So the negative charge will come out like this, and acid, or you can say acidic salt will be come out from the reaction, and we get the alpha beta unsaturated acetic acid as a product, and we have side product will come out acetic acid like this. O negative will abstract the proton from the reaction, or you can say from the H2 molecule, and convert into acetic acid. This is side product, and alpha beta unsaturated acid is a as a product. So this is the mechanism of the Perkin condensation reaction. It is important for your competitive examination. So move further to the another reaction. We have another reaction, Wittig reaction. It is or most important reaction in for the CSIR net, or you can say GEM, IIT GEM. So in Wittig reaction we have a carbonyl group, and we have phosphonium yield, or phosphonium ylide. In presence of diether or THF as a we use as a reagent. So in this reaction, the carbonyl group convert into alkene. So let's see what is the mechanism behind this reaction. So we have carbonyl group CH3, and we have phosphonium ylide PPH3 positive charge. The negative charge of the CH2 will attack on the carbonyl group, O negative, CH3, CH2, and phosphonium ylide PPH3 positive. The negative charge of the oxygen will attack on the positive charge of the phosphonium, or you can say d orbital on the phosphonium halide. So we have 4-member ring as a transition, or you can say as an intermediate, or you can say transition complex. So this is the 4-member cyclic ring will produce in the reaction. So let's see what is the going on next. So the oxygen and carbon bond pair move to the oxygen phosphonium, and the phosphonium carbon bond will come from the carbon bond. So we have CH3 and double bond CH2. This is we have get product, and the side product we have PPH3 double bond oxygen. This is a side product. So this is a simple reaction mechanism behind the Wittig reaction. So this is most important reaction. Let's move further. Another reaction we have Reformatsky reaction. In Reformatsky reaction we have alpha halo ester and carbonyl group, or you can say aldehyde. In presence of zinc, it's convert into alcohol group. So let's see what is the mechanism behind this reaction. We have alpha halo, Br, we have alpha halo ester C2H5. In presence of zinc will insert in the Br and CH2 bond. So Br, zinc, CH2 and ester group C2H5. So here zinc is a metal, and on the metal we have a slightly positive charge, or you can say partial positive charge, and on CH2 there is a partial negative charge. We have a aldehyde in this reaction, and the negative charge of the CH2 group attack on the carbonyl group CH3, and we have this group CH2 oxygen C2H5. We have a product like this. So this is a Reformatsky reaction. Let's move further. Another reaction. This is a novel gel condensation reaction. We have another next reaction. This is the last reaction we discuss about this. So in novel gel condensation we have a aldehyde group and active methylene group. In presence of pyridine is a you can say as a weak base. Pyridine extract proton from the active methylene group, and active methylene group attack on the aldehyde and convert into alpha beta unsaturated acetic acid. So let's see what is the reaction behind this novel gel condensation reaction. So we have a active methylene group. So this is methylene group, sorry, CH2. This is methylene group, or activated by the electron withdrawing group. Activated by the electron withdrawing group CH2 C2H5 oxygen C2H5. In presence of pyridine is a weak base, extract proton from the most acidic side, or I am going to like drawing like this, or you can say I am going to showing like this reaction. Extract proton from the most acidic side, and we have enolate. We have an enolate in this reaction H5 oxygen O negative, sorry, oxygen CH negative oxygen C2H5. Further, we have aldehyde in this reaction, hydrogen CH3. The negative charge of CH2 group attack on the carbonyl group and form CH2O negative CH uh, C2H5 C2H5. Further, the hydrogen will introduce the reaction and convert into it is to as a leaving group, and OH negative extract proton from the most acidic side, or the hydrogen, the bond pair of hydrogen extract by the proton, and hydrogen forced to the OH negative as a leaving group. So we have CH3 and CH double bond C and electro withdrawing group. So this is alpha beta unsaturated acetic acid get as a product. So this is the simple name reaction we are discussing. It is a part 1, and we will come with the part 2, the another name reaction of the carbonyl group. So thank you for the watching. My name is Ankit Diwan. Thank you. हाँ भाई